Now, in the next few slides, we will be explaining some very low-level information. So if you get confused, don't worry, you don't need to memorize anything, just try to understand as much as possible. By differential state, we mean the different signals or USB logical states we may or we can achieve by applying different electrical states on the data positive and negative lines. For full and high-speed devices, to send differential state 0 to a USB device or to the host, of course it depends on the direction of the data, if we want to send it from a USB device to the host or from the host to a USB device. So again, to send differential 0, the USB port or USB controller applies high voltage on the data bus or data line minus and low voltage on the D plus or data line or data bus plus or positive. And similarly, to send differential 1, USB port applies high voltage on the D plus or the data bus positive or data line and low voltage on the D minus. And here you probably noticed that I'm showing you also the logical or the electrical states for the low speed or for the USB low speed. Sometimes I will be showing you the case of USB low speed just to let you know that the signals may differ depending on the USB version or depending on the USB speed. So you see, to send differential 0 in USB low speed devices, you apply different voltage levels on the data lines in comparison with the full and high speed devices. For simplicity, we will be mainly concentrating on full speed devices. So again, to send differential 0 on USB port applies high voltage on the D minus and low voltage on the D plus, and to send differential 1, USB port applies high voltage on D plus and low voltage on D minus. Now you might be wondering, why do we need two lines to send 1 and 0 logical state? Can't we just do it simply by using a single data line? So yeah, just let's say only D positive. The port can apply here a high voltage and the other end of the cable will receive high voltage, and similarly for low voltage. Can't we just use only one data line? Why do we need two data lines? The answer to this question is not really, at least without losing the reliability of USB. These two lines here, the D minus and D positive, are actually the main feature that makes USB resistant against the noise coming from the environment while running in such high speeds. And because of these two lines, we call USB a differential protocol, because it relies on the electrical state applied on two data lines and takes the delta between these two lines to figure out the actual logical or differential state on the bus. So by using this differential principle or differential, any noise applied to one data line will be applied also to the other line. And because USB is differential, the noise will just be in most cases ignored and will not harm the final differential state. So let's say during moving the data from the host to a USB device, a noise signal affected both data lines and caused a small increasing in voltage on both data lines. This 100 millivolt, as said, will be applied on both data lines and will just be cancelled and will not affect the final differential state. And here notice the standard high voltage on data lines is 3.3 volt. And the low voltage or the standard low voltage on data lines is 0 volt. And USB specifies that the minimum difference between the two data lines should be at least 0.2 volt or 200 millivolt. So USB port will recognize, or let's say will consider, one line is higher than the other if the difference between these two lines were 0.2 volt or more.